something like that. It works in this way. It could work based on the pressure of the water, or we could have other types of sensor. Actually, we can have some sort of sensor based on the conductivity of water, and there could be uh, um, uh, many other let's say form of sensors. Anyway, this system works in this way. We give a set point. Let's say we will have a interface. We type 8 on our interface, and this interface transforms this input value to a certain voltage. Let's say it transforms, for example, if it's enter 2, it transforms this 2 to 0.2 volt. Okay, it goes to the summation point. On the other hand, actually our sensor passes a signal showing the level of tank. The summation of these two goes to our controller, which can be a PID controller, for example, and a process is done on this signal, which is in form of voltage or something. But we want to actually control our pump using this voltage, but assume the voltage coming out of the controller is too low to actually run this pump. Therefore, we need an amplifier to increase the amplitude of this voltage. So the pump actually works because of the incoming voltage. Okay. Then actually, according to this voltage, let's say the stronger the voltage is, the higher is the volume of water. Actually, we need to find a transfer function for our pump. I don't know, I don't remember what transfer function I used, but I searched internet, or I used this, I found something like pump. In other examples, I used that transfer function for pump. In fact, pump transforms the voltage into flow rate. Okay, then a certain flow rate enters the tank. Then tank actually stores the water, but there is a drainage at the bottom of the tank, and water goes out of the tank. But we already know the mathematical and block diagram of a tank. Therefore, we know what happens to this part of what happens actually in this part of our control system. We already know. If I want to, but let's say I have to actually add 2 points before showing the block diagram of this control system. I have to say that definitely there is a limit for our electricity here. It means the output of the amplifier cannot be more than a certain amount, and it cannot be less than a certain amount. Let's say it cannot be less than, for example, less than 0. The same thing can be said also about the pump. The output of actually there is a pump has a capacity. It cannot pump water more than that capacity. For example, a small pump can pump, I don't know, tons of water per second. Therefore, there is a capacity, and it cannot actually have a pump a negative amount of water. It means a pump cannot suck the water inside the tank. Just remember this, then I actually explain more about this. If you have the text, actually our manual, the manual, this part of manual is not uh, actually the picture is not uh, printed so properly. Therefore, you have to actually I have to show you this picture. This picture is better. As I said, we have an analog digital interface at the beginning. We enter a set point. This interface converts the given set point into a certain voltage. On the other hand, the level of tank is measured by sensor, and it's transferred here to the summation port in sort of in sort of a voltage. In this summation point, these two values are uh, summed up, and the result, which is called error, comes to our controller. In this case, you put a PID here, controller here. Actually, PID controller works on the signal, and the output goes to an amplifier. The amplifies the voltage. This is saturation. This is what I actually explained on the control system picture. Actually, the schematic picture. As you can see here, this saturation actually limits the output of amplifier. As I told you earlier, the amplifier output cannot be more than a certain amount. For example, it cannot be more than 220 volt, or it cannot be, for example, be negative in this case. This delay is you can also put this delay after pump, doesn't matter. This delay is there is a certain delay when a pump receives a voltage, and when actually the pump starts to pump water. Therefore, we need a delay in this part. You can also put the delay after pump, doesn't matter where you put your delay function. This is our tank. Actually, what comes inside, something is done on it, and at the end we have a certain level of water. This tank, I showed you earlier, this tank is this model. Actually, there's a Q in and an H, H indicating the level of water in the tank. Shown it. I show you what this is actually the complete block diagram. Okay, there is this there is a small mistake here. This should be a start from here, from H, but I made a mistake here. Sorry for that. Anyway, another point I have to add to this actually to this design. In order to be able to uh, actually control the level of water at the maximum capacity of tank, the pump should be able pump water uh, with the flow rate equal to the actually outgoing flow rate when the level of tank is at maximum. That means what? Assume that our tank has the maximum capacity of 10 meter. Sorry that I say the capacity in meter, but I mean the maximum level of tank is 10 meter. At this point, actually when the tank level is 10, we have a certain Q out. But if we have a very small tank, let's say if the let's put some number here. If the level of tank is 10 meter, then the Q out at this case will be let's say, just assume that the out the actually the outgoing flow rate is, for example, I don't know, I don't have any number at the moment in mind. Assume that, for example, is 5 cubic meter per 5 cubic meter per second, for example. Okay, this is the maximum Q out because the level of tank is at the maximum height. If our tank here is not able to pump 5 cubic meter per second, we cannot, first of all, we cannot reach that level. Secondly, if for any reason we reach that level, we cannot keep it because, for example, because the our tank is too small or too weak. We can, at maximum, we can pump 4 liters per second. It means at this level, always the pump is emptying with 1 cubic meter per second. Okay, I think there is no need for more explanation. I think I made my point here. Therefore, our tank should have the maximum capacity higher than the maximum Q out. That's it about the introduction of our control system. In next video, I will show you how to actually make this program. Thank you for watching this video. I hope this video was helpful for you.